So my name's Stephen Poulter. I'm an astronomer here based at the South African Astronomical Observatory. And I'm going to give you an update about our Intelligent Observatory program. I've spoken to you guys about this before, so this talk is basically an update about it. But just to remind you, give you a background context of what the SAAO is, obviously this is the headquarters. Our telescopes are based about 350 kilometers away near the village of Sutherland in the Karoo. And we have, I guess, three groups of telescopes. There's a group of telescopes that we collaboratively operate in collaboration with other institutes. For example, the Southern African Large Telescope there in the corner is the biggest telescope we have. We then have maybe another 20 other telescopes that we either collaboratively host or just purely host for other institutes around the world. And then we have our kind of core workhorse telescopes that the SAAO fully owns and operates and maintains and develops and that sort of thing. So just to remind you what the vision of the Intelligent Observatory is, it's always good to say why we're doing this. Basically, it's in order to better serve you, the community, the users. And when we'll do that, we'll want to be able for you to be able to submit proposals or observations at any time, rather than kind of semesters or trimesters. So this will be able to, so that you can do then science on any time scale, not limited to say when you can actually travel to the observatory and make observations. We want to be able to allow you to either observe in Sutherland or Cape Town or maybe anywhere else in the world. We'd like you to be able to observe manually at the telescope, or maybe a queue observed or service observed. We want to be able for our telescopes to respond to alerts, either generated by you or by automated alerts, and basically enhance our national and international collaborations with you. So what exactly is the Intelligent Observatory? It's basically having all of the telescopes there on the plateau in Sutherland incorporated into a single intelligent observatory, and therefore enabling us to do better coordinated science across all the telescopes in this so-called multi-messenger, this era of multi-messenger astronomy, and thereby advancing the SAAO into the so-called fourth industrial revolution. So we're going to have to build on modern-day communication technologies, a lot of automation, and the use of intelligent algorithms. So where to start? So we started with our three workhorse telescopes, and so about 6-7 years ago, in order to use these telescopes, you had to go to Sutherland and manually operate them. And to just give you an idea of the age difference, this telescope here is our newest telescope. It's more than 10 years old now. This telescope is about the same age as me, more or less. And this telescope here, even though it's the biggest one after SALT, is about the age of my mother, okay? So just give you an idea. So there's a wide range of technology ages there. But now, since we started the program, we've now upgraded all three telescopes so that they can now be fully remotely operable. So we've developed all the software in-house, and yeah, you can operate these telescopes from wherever you like in the world. You don't need anyone else in the dome at all. And so the photograph on the right is kind of our first international user of one of our telescopes. So if you want to use one of our telescopes remotely, this kind of photograph gives you an idea of, what you need. You basically need, a monitor to operate the telescope, a monitor to operate the instrument, another monitor to get the video and audio feed, and another monitor there in the corner to get the weather information. So that's your minimum requirement in order to operate our telescopes. And so here in Cape Town, we've built our kind of flagship remote control room, and I think many of you have seen it already, and so you're welcome to go and check that out later as well if you like. Okay, so that was our first milestone in this project. So the next thing to do was was to fully automate these telescopes. So we chose the newest telescope as our first telescope to fully automate. And we've now completed that. That telescope is now fully automated. You don't need to go there at all. You don't need to remote control it. What we've done at the highest level is we have adopted the observatory control software system from the last Crumbus Observatory. So now, instead of operating the telescope, you have this web interface in which you can manage your proposals, manage your observation requests, and all that sort of thing. You define your observations through this web browser, and it will be put in the queue, and this will take care of everything for you. But we didn't stop there. We also wanted to produce final data products. So now with that 1 meter Lesedi telescope, it can do spectroscopy and imaging photometry. Within less than a minute of obtaining the spectroscopy, via a web browser, you can get a fully flux calibrated and wavelength calibrated of your target spectrum. Okay, so the next step then was, how do we basically eliminate the astronomer entirely? Okay, so we've removed you from the telescope. You can stay at home. The next step was where you didn't have to even operate the telescope anymore. You could just submit your observation blocks to the queue. So the next step was to eliminate you entirely. And the observatory control system allows that to happen. You can now programmatically submit observations to the queue. And so you either write your little script to programmatically do it, or you can have other telescopes talking to this telescope to request observations. So one example, the obvious example, is we can write scripts that search the gamma ray burst alerts, and we can do follow-up, put those observations in the queue. Another example is in Sutherland. There's a new telescope located here. It's part of the NASA Atlas network of telescopes, which is searching for near-Earth asteroids. So what we've done is we have Lesedi listening to the Atlas network of telescopes for rapid follow-up of possible near-Earth asteroids. So there's no human intervention here anymore. It just listens and puts it in the queue and then makes observations. And since earlier, actually this is an older slide, so since beginning this in January this year, we've received over 170 requests to follow up on new near-Earth asteroids. We've observed about 85 of them, and I think as of about a couple of weeks ago, 71 of them, which have been identified and followed up by a 1 meter telescope, and now being formally registered in the official Minor Planet organization. If there ever is to be a dangerous near-Earth asteroid, it's very probable that this telescope will be the source of the bad news. Okay, so now Lesedi is fully automated. We can now do science on all sorts of timescales. So you may remember last year the deliberate act by NASA to slam a spacecraft into the minor asteroid, the minor body called Dimorphos. And because we knew what time that impact would occur, we could submit the observation request to the Lesedi, and we nicely captured the quite spectacular plume of the impact. On the other time scale, we can now monitor objects for many months or years. So this is an example of monitoring a micro-lensing event. So this is an event where some unseen object passes in front of a background bright star, and the brightness of the background star gets brighter as this this dark object acts as a gravitational lens as it passes in front of the background star. And you can see here there's a kind of a triple brightening of the star. So we believe this to be some sort of binary system that's passed in front. Again, on the kind of intermediate time scale, so this is a response to, we had two collaborators, groups of collaborators, one in Germany and one in the UK, who alerted us to a potential new, one of these new white dwarf pulsars. There was only one known, and earlier this year, two independent groups alerted us to a possibility of a second. And within days, we were able to obtain an almost 6-7 hour photometric light curve of this system, where we could quite clearly see these pulses on a few minute time scale. And then this rather busy plot, sorry, it's quite busy, but it's just to demonstrate then how the power of being able to then collaboratively combine observations from multiple telescopes to produce basically great science. So that same system, the white dwarf pulsar, was followed up with Meerkat, and you can see the kind of radio pulse there, more optical observations. We also obtained high-speed photopolarimetric observations with our 1.9 meter telescope in Sutherland. And then there's high cadence observations, spectroscopic observations using SALT. And then it was also followed up within a couple of months with various X-ray satellites as well. And so before you know it, we had a couple of papers, one in ANA and one in Nature Astronomy. So finally, what we're going to do next, so what I've spoken about so far is all software, but there's a couple of hardware projects on the go as well. And last year we began the construction of an instrument port to put on our 1.9 meter telescope. So this instrument selector port will enable us to put more than one instrument on the telescope at once. So now we have the ability on the 1.9 meter to switch between two instruments, which usually only happens 3 or 4 times a year. Now we can do it multiple times per night. And as of about last week, this instrument selector port was mounted on the 1.9 meter telescope, so it's now ready for another additional instrument to be integrated into it. And okay, I think my time's up. Thanks for listening.
Thank you.